Complete, neat, clean swim. We're going to show you some swimmers that do their own thing. Whoa, whoa, whoa. Those get hectic. Those are hectic swimmers. Right. Swimmers on tuck. Right. Let's go. That is the sine graph, f of x, and we're calling it graph f. The name of the graph, graph f, and that is the cycle of the graph. Let's leave these questions down and let's now do a cos graph. So here goes. We're now taking this out. Remember these concepts. Remember these concepts because now we're now going to be doing a cos graph. Let's call the cos graph G, just for argument's sake, just for fun's sake, so that you don't see that every graph is given by f. It can be given, the most commonly used alphabets, if you're in grade 10, 11, and 12, you should be knowing is f, g, h. Right. So g of x, the function, is given by 3 cos x, for x being an element of 0 to 360. Now you all might be asking, what if the graph was from minus 360 to plus 360? No problem. Just extend it to the negative and continue the pattern on the opposite side. But remember, your graphs always start from your y-axis, so pay attention. So we've got the amplitude of the graph. Let's first put, what is the amplitude of this graph? Let's change it. Let's make it 4. Some of you parents, some of the parents are watching the show, and let's see whether you are picking up on this concept. Okay, what is the amplitude? 4. What is the domain? The domain, where will the graph lie? Between how many degrees? There we go. From x less than or equal to 360, but greater than or equal to 0. What is the range? We said highest to lowest, or in fact, lowest to highest. So your lowest to highest, if it's the highest is plus 4, the lowest will be minus 4, so it will be from minus 4 to positive 4. And we put a square bracket because these numbers are included. What is the period of the graph? 360 divided by 1. 360 divided by 1, which is equal to 360 degrees. And there you go. The parent, you have scored yourself 8 marks in the exam. Okay. I actually don't even know who the show is all about anymore. Really. Because we meet people in the street and they say, you know what? My kid doesn't want to watch the show. I've got to beg him and drag him. But I'm watching your show. Guys, if your parents are scoring 80% and you are failing, there's something seriously wrong in this country. Let's get started. Right, so we've got this here, and now we need to sketch the graph. So we draw our swimming pool. There we go. We're going up to plus 4. We're going down to minus 4. Our normal Cartesian plane, 90, 180, 270, 360. There we go, 90, 180, 270, 360. Okay, guys. It's a cos graph. Does it start at 0 or does it cut first? Yes, it cuts first. So that means it starts. This swimmer doesn't stand on the floor. He climbs up. He goes to the diving board. That's your diving board. He starts at your height. And now he dives first. He doesn't jump in the air like the sine graph. So he stands on the diving board and he cuts the water first. So he's going to hit a dive. He's going to come, he's going to dive. And after how many degrees will he make a cut? He can cut at 30, he can cut at 45, he can cut at 60, or he can cut at 90. What determines that? I told you, degree change. 90 degree divided by that number is equal to the change. So 90 divided by 1 is how much? 90. That means he's going to come down, cut at 90, turn at 180, cut at 270, and stop at 360 degrees. And that is the path of the cos swimmer. The cos swimmer starts at the height, hits the water, turns. Also, very neat graph, very neat, very clean graph, behaved graph. So here's the cos graph. You might ask, what if that number was negative 4 cos x? You might ask, what if that number was negative cos x, now 4 cos x? Now you've got this graph. Let's just do a negative one just to show you.